Okay, so picking up where we left off with the last video, if you know an area or you know a probability, you can work backwards with StatsMate to find the z-score or the x value that corresponds to that. You'll still use the normal distribution screen, and instead of typing in an a value, because you won't know the z-score or the x value you're looking for, you'll actually type in the known probability, and StatsMate will calculate A for you, and the A value will actually be your answer this time. So going through an example, if you want to find a z-score so that the area under the standard normal curve to its left is 0.4561. Since you have an area to the left, it's telling you to the left. You want to choose the lower tail in StatsMate, and you type in the area that's given to you in the probability field. So you'll type in 0.4561 in the probability part and press done. You do want to make sure that your mean was still set at 0 and standard deviation was set at 1. Otherwise, it's not going to give you a z-score, it's going to give you something else. The z-score pops up in the A field, and when you round it to 2 decimal places, you should get negative 0.11. If you want to find a z-score so that the area to the right is 0.58, the only thing that changes this time is the areas to the right, so you want to change to upper tail. You'll still type the given area in the probability part, you'll type in 0.58 next to probability, press done, and the number that pops up in the A spot, the top box, you round to 2 decimal places, and that's the z-score you're looking for. That's negative 0.20. The tricky one is if you're asked to find z-scores that separate the middle section of the distribution from the area in the tails. So in this case, we want to find z-scores that separate the middle 60% of the distribution from the area in the tails. What that means is you want to start with a picture. It means that you're looking for a negative z-value and a positive z-value that are the same distance away from the mean, and the area in between those values is 60% of the total picture. That means that the tails, the lower white section and the upper white section, both have to be 20%, because when I add all of the percentages together, I always have to get 100. The way that we approach this problem is we want to find one of the z-values, either using lower tail or upper tail, and the knowledge that we have 20% in the tail. I always find the negative z-score first. That's just how I like to do it. So I find the z-score so that the area to its left is 20%, or 0.20. The way that we do that in StatsMate, since I'm looking at the area to the left, I should be using lower tail. Oh, and I have the wrong inequality sign in there. But it is lower tail. It should be x is less than or equal to a. Type in the area of 0.2 in the probability section, press done, and it gives you a z-value in the A field. Okay, that z-value should be negative. If it's not, you probably picked the wrong tail. You want to round that z-score to 2 decimal places. That z-score should be negative 0.84. That means that the positive value on the other side of the shaded area should be positive 0.84. They're equal distances away from the mean. So my updated picture should look a little like this. It's hard to get the shading on this picture, but I can update it so I know the z-values that separate that 60% are negative 0.84 and positive 0.84. There's a notation that you have to know that'll be more important when we get into confidence intervals in the next few chapters, but it's this z alpha. There's a z, that's the z-score, still means number of standard deviations, and then alpha is this Greek letter that's a subscript. This always is talking about the area to the right. Z alpha represents a z-score, so the area to the right is equal to alpha. So if I wanted to calculate the z of 0.12, that means I'm looking for the z-score so that the area to the right of that z-score is 0.12. I always use upper tail when I'm looking for z alpha because it's always talking about area to the right. I'll type in the known area of 0.12 in my probability field. When I press done, it'll give me my z-score in the top box in the A box. In this case, that z-score is 1.17. You just need to know that that notation always means upper tail, just like percentiles always mean lower tail. So that leads me to this example, finding percentiles. If you go back to that IQ scores question we looked at earlier, if I want to find the 94th percentile for the IQ scores, that means I know the mean is 100, I know the standard deviation is 15. The 94th percentile means I know the probability or the area that I want is 0.94. I can put the mean and standard deviation in StatsMate. I changed the area type to lower tail for percentiles because it's always talking about the amount less than or equal to. And the desired percentile is your probability. So I'll put 0.94 in my probability. The calculation in the A field is the IQ score that corresponds to the 94th percentile. In this case, that IQ score would be 123.32. I don't think they measure IQ scores in decimals, so you would just use an IQ score of 123. There are some problems practicing all of those skills in the textbook that you should use StatsMate to answer. If you weren't in class to do this, you should take some time to do it now, review parts of the video from this video and the previous if you need some help.